Hello everyone. In this video, we will be discussing about minimum number of teeth on wheel and even pinion in order to avoid interference. I suggest everyone to watch the video on the topic interference on the involute gears, which is already posted in our channel, so that it will be easy for you to understand. So all the terms whatever I will be using. So first we will discuss about the minimum number of teeth on wheel in order to avoid interference. So we already discussed in order to avoid interference, the addendum circles for two mating gears must cut the common tangent to the base circles between the points of tangency. So the limiting condition reaches when the addendum circle of pinion and wheel pass to the points N and M. So already we clearly discussed in the previous video where the interference on the involute gears we discussed. So just have a look on that, so that I need not to explain what is this M, what is this N. So initially from K to L only the mating point will be there, and it will extend in the left side till M and the right side till N. So already we discussed. So to do this, let me consider let small t be the number of teeth on the pinion, and capital T be the number of teeth on the wheel, and M is nothing but the module of the teeth, and small r is nothing but pitch circle radius of pinion. So pitch circle radius of pinion can be calculated by using the formula M into the number of teeth on the pinion divided by 2. Next one is the gear ratio, which I am denoting it with capital G, which is nothing but ratio of number of teeth on the wheel divided by number of teeth on the pinion, or even it can be also written as capital R by R, capital R by small r. And next one is nothing but phi, which is nothing but the pressure angle, the angle of obliquity. Already we know all these terms which we discussed. So first let me consider a triangle that is O2MP. You can able to see this is a O2 point. Here I am talking about the wheel, that is at this point, the wheel or gear. So O2MP, only this triangle I think you can able to see where I will be highlighting O2 O2MP. I am talking about this triangle only. Let me consider this triangle O2MP. So I'll go with this O2M square, the formula case. So we will be getting O2P whole square plus Pm whole square. Normal Pythagoras theorem concept if I go means I'll go with that. And since there is a pressure angle, it will, sir, O2M square will be equal to, this O2M square will be equal to Pm square plus O2P square, that we know that, minus, because it is having some mating with the pinion, so minus of 2 into O2P into Pm into cos O2Pm. So this is the thing we need to remember for the triangle equation, which is together equal to O2M whole square. So we know that already it is clearly mentioned what is O2P. O2P, O2P, this is the capital R. So it is whole square, so capital R square plus Pm. So what is Pm? This is P and this is M. So this is nothing but R square sine square phi minus 2 into, again O2P is R, Pm cos. So R sine phi cos 90 degree plus phi. This is the O2Pm. Now by simplifying, since Pm is nothing but what, O1P sin phi, which is equal to R. This is all about angle conversions. Now by minimizing this particular equation, we will get capital R square plus R square sin square phi plus 2 capital R into R sin square phi. Again by simplifying, we will be getting it as R square into 1 plus smaller by capital R into smaller by capital R plus 2 into sin square phi. So limiting the radius of wheel addendum circle, I can write it O2M is equal to R into square root of 1 plus the smaller by capital R into R by R plus 2 sin square phi, which is equal to R already we discussed, which is equal to module into the teeth divided by 2, which is equal to 1 plus same thing T by capital T into T by capital T plus 2 into sin square phi. And AWM, the addendum of the wheel, where AW is nothing but fraction by which the standard addendum for the wheel should be multiplied. So we know that the addendum of the wheel is nothing but O2M minus O2P. Addendum I am talking about. So O2P minus O to M minus O to P. So AWM will be equal to MT by 2 square root of 1 plus capital T by small t into capital small t by capital T plus 2 into sin square phi minus MT by 2. Since O to P is nothing but what? Capital R, which is nothing but basically M2 by 2. So the same thing I have substituted here. By simplifying all these things, finally we will be getting the T value, which is equal to 2 into AW divided by square root of 1 plus 1 by G into 1 by G plus 2 into sin square phi minus 1. So, very important note, use this formula while calculating minimum number of teeth on the wheel and then use gear rotation to calculate the teeth of pinion. So now we have the same case here also, that is minimum number of teeth on the pinion in order to avoid interference. So the addendum circles for the mating gears must cut the common tangent to the base circles between the points of tangency. The limiting condition reaches when the addendum circles of pinion and wheel pass through the points N and M. This is exactly opposite to the previous concept what we discussed here. Instead of the wheel or the gear, we are replacing with what? Pinion. You can able to see that both are exactly the same. So my assumption will be small t will be the number of teeth on the pinion, capital T will be number of teeth on the wheel, M is the module, and small r is the pitch circle radius of pinion, which is the module into number of teeth on the pinion divided by 2, and gear ratio, which is equal to capital T by small t, or else capital R by small r, and phi is nothing but the pressure angle. So how previously we considered the circle O2 MP, here I will be considering here this is a O1, this is the point O1, the pinion center point circle. So it's a O1 N. I will be considering this one O1 NP. This circle I will be considering. The same concept if I go means O1 P square plus Pn whole square minus 2 into O1 P into Pn cos O1 Pn. The same way if I substitute in this means you can able to see that small r square plus capital R square sin square phi minus 2r into capital R sin phi cos 90 degree plus phi. So all this conversion is shown here, and O1 n whole square, which is equal to O1p whole square plus Pn whole square minus 2 into O1p into Pn cos O1Pn, which is equal to r square plus the small r square plus capital R square sin square phi minus 2r into capital R sin phi cos 90 degree plus phi. So which is equal to r square plus r square sin square phi plus 2r capital R sin square phi. So the final equation will be getting r square into 1 plus capital R by small r into capital R by small r plus 2 into sin square phi. So the limiting radius of the pinion addendum circle will be O1n equal to r into square root of 1 plus capital R by small r into capital R by small r plus 2 into sin square phi, which is equal to mt by 2, because we know that what is the r value, which is equal to square root of 1 plus capital T by small t into capital T by small t plus 2 into sin square phi. So let APM be the addendum of the pinion, where AP is a fraction by which the standard addendum of one of module for the pinion should be multiplied in order to avoid interference. So the previous concept for the wheel what we discussed, the same substitution as it is if I do mix. Finally I will be getting the T, which is equal to 2AP divided by square root of 1 plus G into G plus 2 sin square phi minus 1. So this completes this video. This is a very important topic in the exam point of view. So we need to draw the sketch and we need to start the derivation with these assumptions, and we need to do all these things. So in examination they ask it individually, that is the minimum number of teeth on the pinion and even minimum number of teeth on the wheel. Individually they will ask, accordingly we need to write it. Thank you.